Hi, I'm Eric Lenask here at Editor's Day in Santa Clara. From Zeidman Technologies, I'm talking with Jacob Harrell. Jacob, thank you for joining me. Good to have you here.
Thank you very much for the opportunity. I'm really excited to be here to talk a little bit about the products we're doing.
Fantastic. So you're in the IoT space.
Mm-hmm.
How is the IoT industry changing? What are the things that you're seeing changing?
So we see a lot of activities in the IoT. On our side, we concentrate mostly on the things side of the IoT, mostly on embedded development. We see a lot of companies that are trying to take hardware devices and connect them to the internet and be able to do things with that. Obviously, the data is very critical, but we decided to concentrate on the embedded development side because we see a need there. There aren't as many tools available today for helping on the development of the devices themselves.
So understanding that some of those things don't exist, how has that helped you create a roadmap for the company?
Yeah, so we were looking at what is needed in the market. It basically started from the personal experience of both Bob Zeidman, the founder of the company, and myself and some other people. We were developing a lot of different products in this field, and one of the things we saw was the issues that are out there with the real-time operating system. In many devices, you don't want to use the real-time operating system, so you start developing without it. But in reality, you end up writing the operating system. So the first tool that we released, it's called CentOS, and the tool is basically generating your real-time operating system for you. So it's not a real-time operating system the traditional way. So there is no executable or libraries or file to load to the device and run. But we take, as input, we take your application and we generate a real-time operating system around it that will be extremely efficient for you in terms of memory and power management and speed of work.
So how is that different from what used to be done?
So traditionally what people used to do, they used to pick a device that they think it's a good fit for the design. Mm-hmm. They would look for an operating system that actually runs on the device.
Okay.
And then we'll start learning the operating system that in many cases has like 180 to 200 function calls. Mm-hmm. And then start developing the application based on the capabilities of the operating system and the device. One of the things we're advocating is look at the application first. Figure out what your device needs to do. Once you figure out what the device needs to do, you can go and write the code for it, look at the available devices, use CentOS to generate the operating system that you need to run on the device. CentOS will take basically the application code that you have, plus drivers and libraries. We're using 5 primitives that are defining the relationship between the tasks, the communication between the tasks, the use of semaphore and mutual shared memory and events. You also have to write a configuration file, which is a text-based file that describes the overall system architecture. And we generate a C code that includes your user code and the necessary part of the operating system for this specific application. At this point, you can basically compile it to any device. So CentOS basically is generates a fully portable operating system because any device that supports C compiler can basically run this operating system.
Got it. Very interesting. Now, does that also include, so when you're talking about, you said, look at the application first, does that also include an understanding or an assessment of the application to make sure it's been properly written?
Yeah, so right now the tool that we have, CentOS, is basically generating the operating system, but it is analyzing your code. So it will give you warnings about some of the issues that we see usually with operating system, but our next tool to come is more of an analytical tool that will analyze your code and will give you warning and will try to fix some of the typical problems like priority inversion and task starvation, deadlocks in a typical embedded system.
Now, who are the typical folks that you're marketing this to?
Yeah, so the sweet spot for CentOS is basically all the smaller devices in the market. Mm-hmm. So mostly CPUs that are limited in terms of memory and processing speed, 8-bit and 16-bit devices. But there's also about 40% of the market of people that claim they don't use an operating system at all. But in reality, they actually build the operating system and write it themselves. So this could be a perfect tool for them because it will generate it for them automatically. It will generate code that is both reliable and secure because every time you generate the code, it's a new implementation of the operating system. So you don't have the case where some of the open source operating system, you can just download from the web, learn the vulnerabilities, and attack other systems. This is a unique implementation for your specific needs.
What else do you have on the roadmap?
So as I said, we already start thinking about the next generation of CentOS, that one that will include some analytical tools to analyze your code and give you some warning about problem and potential problem in the system. We're also looking at other tools that will help generating some other parts of the operating system, like the drivers, communication. And eventually, we're hoping that we'll get to the point where with a single button click, you can generate your whole embedded system by just defining what are the functionalities that you want the system to do.
Wow, that's fantastic, and that will generate huge efficiencies for those developers.
We definitely hope so. Yeah.
Fantastic.
Yeah. And we already see in some of the projects we already done that there is a great advantage in terms of both memory, power consumption. We did some benchmark against some other operating system in the market, and we see improvement of about 30% on flash and more than 50% on RAM. That translate immediately into the size of the devices you use in terms of cost and the power consumption for the device, which is critical for Internet of Things.
Absolutely. Jacob, thank you so much for joining us. It's great to have you.
Thank you very much.